Then you also hear the mirror, sort of. Yeah, but that's noises. That's why I'm confused. I hear it starting. Yeah, but I think it's also electronic first place. So, yeah, they basically have like first.
Please be seated. Meneer de promovendus, het college voor promoties deze universiteit door ons vertegenwoordigd, heeft kennis genomen van uw proefschrift en de bijgevoegde stellingen en is bereid deze door u te horen verdedigen. Ik verzoek u plaats te nemen.
Thank you.
Is er iemand uit het publiek die met de promovendus van gedachten wenst te wisselen? Zo niet, then I pass the first opposition to Professor De Oliveira from Sao Paulo.
Thank you, Mr. Speaker. Dear candidate, I think you deserve congratulations on a nice work. I believe your results do contribute to advancing the state-of-the-art in the field of multidimensional visualizations, and in particular in similarity-based point placement techniques. In chapter 5 of your thesis, you've addressed your research question 2, which was stated as, how can we enhance multidimensional projections with explanatory mechanisms that provide local and automatic explanations of the perceived patterns? You present a very interesting solution to the problem and illustrate its potential with several practical examples. Nonetheless, in your propositions 2 and 8, you acknowledge the limitations of visualizations in that they not always succeed in achieving their goal of helping users to understand the data. Moreover, your initial global hypothesis is stated as, how can we help a wide range of users to easily visually reason about and explore the notion of similarity present in large multidimensional data sets? So I think this end-user perspective is indeed very relevant to your work. So considering this, your broad initial research question, and considering your propositions, I missed in your thesis some type of actual user feedback on the effectiveness and usefulness of the proposed techniques, in particular those described in chapters 5 and 6, in helping users to achieve their goals. You may, of course, agree or disagree with this criticism. In either case, I would like to understand why, and I'd like to listen to your views on this matter.
I learned opponent. Thank you for your question. This is indeed a very interesting question. The problem at hand here is we first had a multidimensional projection and we want to explain it automatically to try to to give some visual cues to the user to make the projection more, how can I say, to have more information about why the points are positioned together and which are the dimensions that mostly contribute to make local similarities, right? We indeed didn't create a mechanism. We didn't follow a user-centered research to have some feedback from the user about what he thinks about this tool, which are the advantages or the disadvantages based on his perspective. Indeed, we miss this point of view. We don't have this kind of feedback from the user, but at least the problem we addressed firstly was to prepare a tool to be able to reason about projections. So we first defined some tools, and we leave this as a future work to have this a more detailed user study to identify which are the most problems that user might address when they use this kind of tool.
I see. So may I?
Of course, no, please carry on.
So if you are given more time to continue your work and you decided to address then this issue that you are now stating as future work, how would you do it?
Well, thank you again for your question. Well, basically, if you were given more time for us, I think a good idea would be to give a very simple data set with a very simple projection to several users so they can understand well which the problem at hand and give them time to work with the tool and try to identify which are the most important issues they find it, which are the most important problems, Repeat this procedure with several users and also trying to motivate them to use this tool, because in user studies, I particularly find it very challenging to motivate users to do that. You have either to pay them or do something that is very related to what they are used to do, and keep them motivated to use this tool for a long time. So, in my opinion, we'll have to, on a future work, find a very easy problem that might be related to what they usually do. For instance, some tasks that they are more accustomed to do, and repeat this with several users to try to understand which are the most common difficulties that they find when you use this tool.
I see. And would you consider actually comparing your solutions with alternative ways of actually providing the same information? Like, for example, in your initial chapter, you mentioned that most current solutions would involve actually combining the projections, so plain projections without your added explanations, with complementary techniques, maybe attribute-based techniques, using brushing and linking, so that would be perhaps a relevant issue actually to see how effective your solutions are compared to other ways of actually giving users the equivalent information.
Yes, indeed, this is a very important topic. What we did here was just an example of how we could contribute to explain projections, but this is just like a modular tool. You have one step which is ranking dimensions and try then to visualize them on the projection. But we can use any other ways to try to extract these relevant dimensions to next visualize them on the projection. So also an additional step will be interesting to compare the results we have here with other techniques that could be attached on our solution, and which we could check if they match or if they can give additional information to us on other tasks, for instance.
Thank you, dear candidate.
Are you satisfied?
Well, if I may, I could have another question.
Yes, please go ahead.
Yes. So actually, this is a more specific question. In your figure 4.4, you compare your bundling solution that's on page 92 of your thesis, you compare your bundling technique with 3 other techniques from the literature, right? Your technique requires at least 3 parameters, right? The beta parameter and K and X as max for the clustering solutions. So I was wondering whether the other techniques do require some parameters, and if they do, how did you parameterize them, and how you made sure that you actually did a fair comparison of the 4 techniques, making sure that you achieved the best possible from each of them for your purpose?
Thank you for your question again. Indeed, our technique to construct this skeleton, we need these parameters. We need to cluster first the data and then create a tree based on this multi-level approach. And then we use this skeleton to bundle our graph and then to next visualize it. We wanted to compare how other bundling techniques would be able to identify some edge patterns based on a simple data set. So we had a very simple data set, and we tried to run these bundling algorithms on all of these techniques. But indeed, each of these techniques have other parameters, and we basically, being very honest with you, we run these other techniques and we try to achieve a good visualization, but we didn't knew beforehand which are the most, how can I say, the best parameters for each technique. What we did is to really try to figure out if the other techniques were able to see the main parameters of this simple data set. So we made a comparison using several setups in different techniques and check how each of these techniques performed on the same data set. But also, to be honest, since our technique used a previously computed skeleton, it's not totally fair to compare these techniques, because our technique uses a skeleton to guide the bundling, and the others have other approaches. So we compared them visually, but it's not exactly totally fair to compare them. But we tried to just create a visual comparison to check if they could capture the same edge patterns.
Thank you for your position. That will now be continued by Professor Linsen from the Jacobs Universiteit Bremen.
Thank you very much. Geachte promoventes, my assessment of your thesis is actually quite similar to the one of the first reader. I think you have developed very nice methods in your thesis. The weakness is a bit on the evaluation side, so there could have been more evaluation, especially involving the user. Since Christina asked about the second part, let me ask about the first part. So when you built your multi-scale tree, so what I was missing a bit was a comparison to just using a single scale tree. And so if you had done such an experiment, what would you have expected to be the outcome of such a study?
Hi, Leonardo Ponent. Thank you for an interesting question. Indeed, we could perform more tests to compare how our tree is performed based on the previous approach, which is the single scale tree, the tree that try to visualize every single data instance on the same scale. But the problem at hand in our chapter is we want to provide a tree that could handle more data. So the previous, how can I say, the single scale tree is very precise and it has its advantages, but in our case, we wanted to deal with more data. So how did we perform? How did we proceed to be able to handle with more data without changing the original tree building algorithm? We provided a procedure to first create a multi-scale clustering scheme and then apply the same tree construction algorithm over each of these scales. Indeed, we could compare better how our technique performs based on the previous one, but the previous one couldn't handle as much data as the multi-scale tree can handle. So if we try to run the original algorithm on a bigger data set, for instance, like 10,000 data instances, for instance, it just can't run. It will consume too much memory. It will requires a huge data dissimilarity matrix, and it will take a lot of time. So in the problem at hand, we have to deal with more data. We couldn't even generate the original tree. So that's why we didn't focus much on comparing the original one with the multi-scale one.
That is true, but I mean, you could have still run it like for hours and let it generate one result, and then really, of course, it's more efficient the way you're doing. No question.
Mm-hmm.
My question was more on the user side. So, what can a user do with you? How would the experience? What tasks could be done with your approach that would not able to do with just a single skill approach?
Thank you for your question. Indeed, this chapter also lacks a more detailed user-based experiment, like giving the tool to a user and trying to make him, giving some tasks to the user and check if he's able to perform this task with our tool. Also, this is something that we want to do in the future. But the problem at hand again is we want to deal with a lot of data, so we provided some mechanisms to allow him to explore data, give some visual cues to make him understand what to expect on each part of this multi-scale tree. And based on the precision experiments we performed, we consider that this multi-scale tree achieves some precision performance, which is really similar to the original tree. So we lose a bit of information, of course, because we have to cluster it first, but we also preserve most of the precision based on the experiment we performed. So indeed, we need more experiments to give the user give us some feedback about how it looks, how it feels using this tool. But we left this part for future work.
Okay. Then next, what you did is you combined that with an edge bundling technique, and this was based on some clustering method. So I think, the quality of your result depends very much on the quality of the clustering method. And if the clustering is bad, then I expect that your bundling makes the impression of the bad clustering even worse because it emphasizes the clustering. Do you have any comment on how this can be alleviated, or how this can be somehow changed, or maybe you have some experience on how bad that actually is?
Thank you for your question. Indeed, this is a limitation of our tool. We use this multi-scale tree to generate that skeleton, to next use this skeleton to bundle the graph. If the clustering part can't generate very consistent clusters, I mean, putting on the same cluster highly similar items, indeed we will have a bad result because elements on the branch of the tree, elements that are not that similar because the clustering didn't find this similarity, are put on the same branches, and the final result will be bundling elements on branches that are not very similar. We could use other approaches, other clustering techniques. For instance, we use k-means because this is a very popular one, and this is also a very simple one to implement. We could find this source code almost everywhere. But we could use other clustering techniques, or even the user might provide by hand which are the optimal clustering for a given data set. So if he gives this clustering as an input to the tool, this cluster could be used to generate the tree, and then he has more, he's more certain that this clustering is a good clustering that will generate a good tree. So this is like a modular tool again. We can use any clustering technique as input, and then we can generate bundling again using this clustering as a previous step.
I'm still continuing, yes?
You can still ask more questions if you want to.
Okay, good. If I follow up on this, when you try to computer edge bundling, you're basically optimizing that with fixed node positions. Ideally, one would optimize the two things together. Do you have an idea whether that would be possible and how?
If I understood, thanks for your question again, but if I understood your question correctly, the problem you are addressing in is that you have another clustering, you will like another clustering scheme to generate this skeleton and then visualize it differently, right?
The question is, right now you're doing first the node placement and then the edge bundling.
Yeah.
Ideally, if you could do that together, you might get an even better result.
Yes, indeed. The only limitation here is that since we use this skeleton to generate the bundling, so this banding of all edges are based on the skeleton of the tree. We first have to generate this skeleton and place it on the visual plane. After that, we use this skeleton to bend the edges. So before creating the bundling, we must have this skeleton placed on the visual map, and then we start the procedure of bundling. So these things are different steps in our approach.
Okay. I have one last question. Or?
Yes, okay, go ahead.
Okay, good. Just more on the future work. You said, well, one of the interesting things to look into would be to embed categorical and relational data together. Do you have any ideas on how to approach that?
Yes, this is also a very interesting question, because when you want to put categorical data alongside with this continuous data, if you just you don't have an exact order how to assign, for instance, numbers to categorical data, and these numbers might give you a false impression of distance. If you want to put to create a data set and want to create to measure distance between elements after that. Indeed, there are some approaches to handle with this problem. We didn't use these approaches on our techniques. We are focused here on continuous data, not in categorical data. Categorical data we just use to label those elements and assign colors to them. But as future work, we could use other techniques to deal with the categorical data. But in our approach, in our work so far, we didn't even address this problem.
Okay, thank you.
Thank you for your position. We shall now be continued by the hoogleraar Latuwik.
Thank you. Dear candidate, first of all, thank you for an interesting reading, and specifically a lot of images and figures in your thesis, because the first 20 minutes when I read it, actually instead of reading, I was just looking at the images and enjoyed it a lot. Actually very unique for PhD thesis, so I very much appreciate it. And I also appreciate for the invitation for this committee, because while not being an expert in the field, because I'm not working daily here, I still appreciate the possibility to actually know more about how people deal with multidimensional data and how to reduce dimensions and how to visualize and so on. And with that respect, actually, because it's not the first time when I'm, talking or listening to our defense of Alex, a PhD student of Alex, I'm actually interested because my impression is that largely the problem when you have multidimensional data is actually how to reduce it so that people actually don't understand what's inside. And this is actually like my impression, that's the main question. Well, thinking about it in like more meta level, actually I realize that very often people, of course there is a point when you collect a lot of data and actually just want to know what's happening inside, and that will probably work because there are too many dimensions and you just cannot do that. We are humans, we have certain limits. But let's say I kind of a little bit know what my data is about, and I'm more curious about actually building a model. And I'm more curious about selecting features which will get into that model, and I have a bit of impression about that. So instead of actually looking into what's the data and visualizing those, more dimensions than 2 and 3 by coloring things and so on, I'm curious actually if we can look at your problem is in a bit reverse engineer, or like the opposite direction. So instead of actually going from multi-dimensions and kind of trying to reduce them into something which is comprehensible by people, doing the opposite. Let's say if I'm looking at some visualizations which were probably prepared by other people or just by me or by your tool somehow, can I somehow guess what the rest of my data is? What features are relevant? Or probably even guessing the missing features in a way because my data is a bit too biased, or I just see some clustering just tends to a certain thing and I just cannot find that the particular representation which represents that missing data, so I may probably guess that some feature is missing. So because I already have quite a long question, to keep it short, instead of going from many dimension to small dimension and trying to represent them, can the same or similar techniques can be used to actually go in the opposite direction and kind of from visualization trying to guess what the data look like, what features are there, and what will be, what features are missing in a way. So, thank you.
I learned opponents. Thank you for your interesting question. Indeed, this is a very relevant problem. We have, for instance, we deal with very difficult data sets. We have a lot of dimensions. We want to explore it. We have to feel how it looks like, which are the most similar groups. And this is indeed a very interesting approach to try to use the visualization to figure out what are the most relevant dimensions that make this group together and how to explore it. Basically, what we did here is we first use the approach of reducing dimensionality to create the visualization, but after that, the user can explore the visualization, try to do brushing and select elements that the projection to put them together since they have some attributes that are similar. And based on these interactive techniques, these interactive actions, user can have a look at the original data. For instance, when he exploring textual data sets, he can grab groups of similar documents and select and visualize which are the content of these documents. So the tool gives you which it identifies as the most relevant elements, as the most similar elements, and next the user can explore some groups to identify which are why are they are positioned together, and which are these exactly single elements like texts or images, for instance. So based on the interaction, he can do the opposite. From the visualization, go to the original data. I don't know if that satisfies your question.
That makes sense. I was just more curious about your opinion on the matter because I see that, again, in my field, more happening in the opposite direction. Very often people start with a small model and trying to guess and kind of explore what features are missing and trying to see. This is, like, for me, a more typical task, let's say. That's why I was curious about your opinion, if this tooling can be applied over there. Do you have time for one more question?
Yes, you have.
This is probably will be a bit easier, or a bit again, I'm even more curious about this part. You actually, in the beginning of your thesis, you mentioned a lot that your tool or the techniques you're using are scalable. However, by the end of the thesis, you more or less position this as more like future work because, okay, I will look into larger data sets or more dimensions. And actually looking again through the thesis once more, I found out that you more claim that you're scalable than actually proving it. And I'm curious, is your premise on the fact that you are scalable, what is based on? Because I didn't really see any experiments really proving it. So,
thank you for your question. Indeed, we have several kinds of scalability. We have the visual scalability, which is we are able to deal with more data and using the limited visual screen more efficiently. So the scalability on this approach is more based on what we can see that we couldn't see on previous techniques. So if we address this problem on several approaches, trying to check to visualize groups of data at time and to not overwhelm our visual space, and we also deal with the problem of data in computational scalability by creating partitions of data and then creating visualizations based on these partitions. So compared to other tools that we are known that are used frequently to analyze data, our claim here is that we created some other tools that can visualize and generate models that don't overwhelm the visual space, and we can also explore them without overwhelming the visual space or also overwhelming the computational resources that the machine, a regular machine has. So this is what we meant with providing more scalability.
Yeah, makes sense to me. Thank you.
Oké, dank u. Oppositie wordt nu voortgezet door de hoogleraar Renadel.
Thank you, Mr. Rector. Geachte promovendus, dear candidate, I also read your thesis with interest. I appreciate that it's very well illustrated.
Thank you.
And I have a few questions from a more theoretical viewpoint, which is my own expertise. First of all, you introduced the notion of similarity trees on page 47, 48, but what I was missing is a more formal definition. It is apparently a graph, a connected graph without cycles. And then what I understand from what you say about it on the neighbor joining algorithm on page 53, what you apparently have in mind is a tree without a root, where all nodes have either connectivity 1, so degree 1 or degree 3. That's more or less what you use as an idea of... and most of the illustrations of similarity trees correspond to it. But for example, the one on the cover page is quite different. Almost all nodes have degree 1 or 3, but there's one with degree 2. There you have a rooted. And if I look at, for example, page 47, I see 3 layout strategies for visual supertrees. And there I see similarity trees with nodes with degree 4. Is that a coincidence or just the fact that it is rather small and you have 2 nodes very close to each other? Or is it one of the same nodes? Please inform us what is, mathematically speaking, the definition of similarity tree.
Hi, learned opponents. Thank you for your question. Can you tell me, please, again, which image are you looking at on this page?
At 57.
57. Okay.
57.
Okay. Thank you.
So the similarity on the left and in the center, they both have one node with degree 4.
Yeah. Thank you again for your question. Well, a similarity tree is indeed a graph that might or not be is a graph that is not, you don't have cycles there, so you can explore it on depth.
Yeah.
Depending on the technique we are using to create the tree, that might be a different tree. For instance, on these techniques we discussed it here, we just gave some examples of how to build this similarity tree. Yeah. The neighbor joining technique, for instance, it doesn't create a rooted tree. Basically what it does, it creates at first it creates a radial tree and then tries to get the most similar pair of elements, create another node and try to how can I say, create this hierarchy by taking the 2 most similar elements and generating a new virtual node. But there are other techniques like the one that we addressed here, which the UPGMA, which this one has a root node, so we can address this tree a bit differently because this is a rooted one. Mm-hmm. So basically, on the examples we use on the thesis, we use this neighbor joining because it is known that is more precise. And we also wanted to just check which are the precision compared to the other techniques. So that's why we put a chart there comparing the precisions. But indeed, this is not rooted. This is a not rooted tree. But what we did to consider like a virtual root is taking the most central node. Yeah. So we just begin to trim the tree, removing the leaf nodes, and the last node that will be left, we just consider it as a virtual root. So we use this root to generate a layout for our trees.
But the node with degree 4 in this, is it an artifact or is it just intentionally there?
Yes, it's intentionally there. Yes, because on the last step, it might has in the last step of the neighbor joining, it takes the three last elements and then join them. So this is like a special node that takes the last elements, which are the most dissimilar ones of the tree, and then grabs them together and create a virtual node to connect them.
Okay.
So that's something of the technique. You know?
Okay. Thank you. Okay. My second question is about the algorithm on page 62, which you nicely describe in pseudocode algorithm, supertree construction. You introduce it on page 61.
Yeah.
And there you say it is a recursive algorithm. But if I look closely at the definition, I see no recursive call, unless what I read on line 9, there you call the function supertree. Do you mean supertree construction? So the one that's being defined here. Okay.
Yeah.
So then I see that is indeed, as you announced, it is a recursive definition, and it leads to some kind of scaling also, multi-scalability.
Yeah. Yeah, indeed. We just put a very high-level algorithm here just to give a notion of what's going on. But indeed, we could try to put it a bit more formally to make it more clear. You know. We could also,
The algorithm you use in it is NJ, which is neighbor joining algorithm, which you describe on page 453. And there, unfortunately, I do not see a description in pseudocode. You just describe it well on that page in more or less natural language. And I had a few questions about it. First, at the end, you define on page 54, when there are 3 nodes left, the final node is connecting when added, and the length of the 3 corresponding added edges, and then you define D1x, D2x, D3x. Should it be L1x, L2x, and L3?
This is actually the distances between this new virtual node to the remaining 3 nodes of the.
It's not edge length. It's edge length you have to define here, or diff distance.
Yes, we have two things.
Yes.
The first one is the add length.
Yes.
And the other one is the distance from one element to another.
Yeah.
So if you sum up the edge lengths, the tree, optionally, it achieves to preserve the distances of the original matrix.
Yes.
So we have the lengths. If you sum up their weights, in the ideal tree, these distances of the lengths will be the same as in the previous input matrix. But not every tree can do that.
No.
So it achieves to do that perfectly, but in the end, it's just an approximation. So,
but in the end, you will also, just to finalize the algorithm, you have to give these edge lengths for these last 3 edges you added.
Exactly.
And here you only define these, which are distances.
Yes.
They also play the role of length?
Yes, we have another step here, which is the equation 3.1, which creates which defines for us which is the length for 2 nodes. So we can use this equation to define the length between those 3 remaining nodes.
Oh, you have to use 3.1 there.
Yes, exactly. So we have the distances on one hand, and you have to compute the lengths on the other hand. Then these lengths can be used, for instance, to visualize, and we can have a notion of similarity between those elements.
Okay. So you have the S, the L, and the D. You have 3 notions here.
Yeah.
And what I try to understand is what was the justification between the formulae in 3.1 and 3.2. You indicate shortly what is the idea behind 3.1, and for the other you only present a definition, but why are they defined as they are? Could you say a few words about that, please?
Thank you for your question. Basically, SIG is the sum of the lengths of the entire tree connecting 2 nodes. They might be neighbors or not. So if they are in 2 opposite positions of the tree, this sum is how is the shortest path between two elements in of the tree.
But in the definition, I see more than a sum. I see another sum, I see a fraction, and I see some constants in front of them.
Yes,
Why?
because we are using here the distance matrix, and we are taking some average here based on the distance. It's just an approximation, you know, of the original distance of the matrix. So if we sum up this distance based on this algorithm, it will lead to what the algorithm thinks it's the optimal way to create a tree where the sum of the lengths between the two leaves are close as possible to the distances of the original matrix. So S is the sum of lengths connecting two elements. L is just the length of one particular branch connecting, for instance, a node I to a newly created virtual node X. And here also we have another definition to the other node J connected to the same virtual node X. And then D is the original distance, is the distance from the distance matrix, which is used as input.
Yeah. Okay, thank you very much.
Thank you. Thank you for the position. Which shall now be continued by second supervisor, Professor Mingham from Sao Paulo. Thank you.
Thank you, dear candidate. I don't have many questions since I've presented you with so many during your work. But one thing that I think it's important to bring out from this work is related to what Professor Cristina was saying, Professor Oliveira was saying. And that was when you have users involved in the process, there are things that you must take into consideration. For instance, having worked for so many years in multidimensional projections and having seen so many people trying to improve the techniques that we have to map multidimensional data into visual spaces, such as two-dimensional spaces, we have come across very interesting cases, use cases for it in final applications. But in the end, the type of presentation that a projection gives us is not very friendly to general users. Why? Most of our, some of our users are very excited about these techniques and what they can do. But these are mostly academic people, scientists, people that are used to statistics methods in their everyday work. But when you go to a final user that is outside the academic environment, this becomes a very obscure way of presenting data. You have contributed, in my opinion, quite well to explain what happens after you map with your data and how to compare, for instance, two different projections of the same data and what they are doing. Because if you use two different techniques, in the end you get different results. And you did a very good job in trying to explain what that projection is doing regarding keeping original distances or keeping the original neighborhoods. However, one question that I put to everybody these days working with this, and it's very important that I hear it from you also, is how can we bridge the gap between the final users and multidimensional projection techniques, knowing already that they, in terms of precision of explaining the multidimensional data, they have very good features.
Hi, Learn Supervisor. Thank you for your interesting question. indeed, when we work with these tools, we are the type of tasks that we use and the type of users we provide these tasks are mostly in academia. It's not that common to provide these tools to end users that are not that used to scientific approaches or scientific questions. Indeed, in my opinion, we should create more user studies to identify which are their main difficulties on using that tools. The tools that we used so far, they have some parameters that might seem a bit hard for end users that are not scientists to use or to understand. In my opinion, to be able to perform these tests and to give these tools to more to end users that are not specialized in that field, we could create tools that are more focused on simple tasks on all simple domains. For instance, if we are addressing with texts and text of a unique nature, for instance, where you're just addressing RSS texts or texts related to some specific topics, you could tune these tools to address this specific topic, to this specific field, and we will have less parameters to give the user. So the tool could be more automatic if you address there to specific tasks and to specific data, and next perform these user tests and identify which are the problems that they face using it to improve, for instance, the usability and so on.
Thank you very much. College voor promotie zal zich enige ogenblikken terugtrekken voor beraad. Please be seated. Meneer de promovendus, het college voor promoties deze universiteit door ons vertegenwoordigd, na kennis genomen te hebben van uw proefschrift en de bijgevoegde stellingen en deze door u te hebben horen verdedigen, heeft besloten u het door u beginnen doctoraat aan de Rijksuniversiteit te verlenen. Uw eerste promotor, de hoogleraar Telia, is gemachtigd u op de gebruikelijke wijze bij deze waardigheid te bekleden.
I'm happy to accept the task assigned to me by the Rector Magnificus. But as the custom goes, I will want first to address a few personal words to the candidate. Dear Renato, I hope that my speech is going to be as fluent as your defense. And as you know, you are the third and I hope not last person that worked together with Professor Rosani Mingim, with Rosani and with me, on the topic of analyzing visually multidimensional data. So our endeavor started in 2011 when we got a joint project, the University of Sao Paulo, São Carlos, and University of Groningen, and we moved then at the topic of this very large topic of looking at multidimensional data visually by using projections. And there was, of course, a first project where your colleague Rafael Martins was involved. There was a second project where your other colleague Danilo Coimbra, both who have already sat on that chair, has been involved. But the field grew even more. And of course, it was very, very interesting to start pushing the boundaries further, and that's where you enter the picture. Actually, if I look at this whole endeavor that took about 5 years, not your PhD that is, but our joint research, I think that one of the results that I'm most proud of is your chapter, forgive me if I don't know the right number by heart, 4, I think, in the current thesis, the one where you show how you visually explain projections by means of color-coding neighborhoods. I recall that early in the beginning, that is in 2011, this was sort of the vision I had. I wanted to generate a simple picture, of course, with fancily varying colors and shades, and it had to have some cushion design inside because I'm a fan of that. And it had to explain the projection simply, visually, compactly, hopefully, even possibly for an end user. And that was your first task on which you started working a few years ago, I think 2.5 years ago. And in a very short time, I recall you were coming with mails and ideas and even pseudocode that I could not read because they were too detailed. You were explaining in detail how you were set up experiment 1, experiment 2, experiment 3. So in the end, I gave up actually reading all this fine print because I realized that you switched from the moment where you need, how should I put it, close advice and being led by the hand to do things, as some master students are, to the moment where I'd rather, shut up and look at the images that you produce. And there I got the feeling that you are on the right path to become a true independent scientist. Many things followed afterwards. So one of the latest developments that I'm also very proud of was the fact that you quickly, in a matter of months, when you visited us last in Groningen, moved from the static data set visualization to the dynamic data set visualization, and that also brings something in the equation that I would like to mention. You collaborated very nicely during this period with a number of different students. So I would like to mention with this opportunity at least 2 names. Paulo Raubert, the creator of the dynamic TSNE projection, who got also a prize at our last year of this conference. And of course, Eduardo Vernier, a bachelor student from the University of Rio Grande do Sul, who will probably follow in your footsteps, that is, look at multidimensional time-dependent data, also with a PhD next year. Your work also created other opportunities in the sense that we have now a project running with Hank Ruiker over here, started this September, in the direction of using multidimensional projections to construct graph layouts. So you were, in some sense, picking up the idea that we originally had in 2011 and blowing it up nicely to feed a number of extra projects. And I think this is a very nice sign for not just me having had a good idea in 2011, of course, but for you being able to take this hypothesis, as we call it, and to create out of it something that can generate future research. Probably the best sign of good work. On a personal level, there are also other things that I have to mention. First of all, you are more scared in our private discussions than today over here, which is probably a good sign that you arrived at the point where you can defend, which is the right word that should be used for a PhD student in his last moments of PhD career and the next moments of his future life, to defend the ideas that you have easily and without being lost into details. You always were a very, very pleasant person to work with. I recall that, of course, we had setbacks in terms of our results, expectations, in terms of what other people thought of our results. I'm not pointing specifically at Professor Linson, but taking the reviewers out there as an example. And you always took them with, how should I say, good humor, and with a confidence that what you're doing is the right thing, and of course you will need to make changes, but in the end, oftentimes, you're more positive than myself, which is, again, yet another good sign that you believed in the work you're doing it well, and you're seeing the end coming in light. You integrated for the time that you have been here, since I have to mention, this is a double PhD project between the Universities of Sarcolars and Groningen. You integrated very well with the group. As I have seen, as I've heard from colleagues, you are always a very, very collegial person, and everybody liked talking with you during work and, of course, also after work. And this is, of course, also the moment to thank the University of Sarcolars and, in particular, Rosanne Minguin for, making this possible, both, of course, financially and in terms of supervision effort. Soon, you will defend again, your work in front of a not identical committee that is on the 5th of September, which is also December, excuse me, which is of course a very important date in the Netherlands as well. It's St. Nicholas Day. And I hope that by that moment, the committee that is going to grill you again will be able to make another very nice present to you. So, once more, thank you for having worked with us on this project. I'm very happy with the results, and let me be then...
All rise, please. All rise.
Pass to the formal part of the defense. Uit kracht van de bevoegdheid ons bij de wet toegekend, volgens het besluit van het College voor Promoties van deze universiteit, verklaar ik Alexandre Telia, u, Renato Rodrigues Oliveira da Silva, te bevorderen tot dokter en u alle rechten te verlenen die door wet of gewoonte aan het doctoraat van de Rijksuniversiteit Groningen zijn verbonden. Als dokter belooft u in de toekomst te handelen naar de Nederlandse gedragscode wetenschapsoefening. Do you promise in the future to follow the Dutch Code of Scientific Conduct? Please be seated. Now that I performed the task assigned to me, let me be the first who congratulates you on your PhD degree and address you as doctor.
Ten bewijze deze promotie overhandig ik u diploma ondertekend door rector magnificus, secretaris en promotores en voorzien van het grootzegel der universiteit. Doch alvorens hiertoe over te gaan, zeer geleerde heer, pleit ik mij van de aangename plicht u ook namens het college voor promoties met de verworven graad geluk te wensen.
Fotomoment.
And as a remembrance to your stay in Groningen, please accept this little present to picture. Hiermee verklaar ik deze plechtigheid voor geëindigd.